Hi, I'm Owen Vance.
And I'm Owen Pearson.
And this will be our demo of our root Goldberg machine from Circuits 2 Lab, EE241.
First element of our Rube Goldberg machine is the capacitive touch piano. We have 4 copper pads. They all have one common send pin from the Arduino, and each copper pad has its own pin going into the Arduino. The common send pin puts out a voltage, and each input pin from each copper pad measures how long it takes to receive the output at the input. And when you put your finger on each key, you add some capacitance to the circuit, which means it takes longer for the input to reach the output voltage from the Arduino. And if this timing is longer than a threshold written in the code, then it's considered a touch on a key. We have a array in the code, which has 5 key numbers, which corresponds to our correct sequence. And we also have a blank array in the code. Every time a key is pressed, that key number is stored in the new array, and after 5 keys have been pressed, the correct array is compared to the created array, and if they are identical, then a 5-volt output is sent from the Arduino to this relay. The relay is it's an electromechanical switch. It has a coil which is powered by the Arduino, and when this coil is powered, it creates a magnetic field which closes the contacts on the switches inside and powers the next part of our circuit.
So, once this mechanical switch is flipped on the relay, this 9 volts from this battery is going to get sent through to this circuit, where it'll be stepped up about 10 times by a transformer. And then that voltage stepped up by the transformer is going to start charging this capacitor. The output voltage of this capacitor is still going to be a DC voltage, but an AC voltage is needed to power the strobe light. So, the voltage is sent through a transistor, which switches it on and off, giving the voltage an AC component. This AC voltage is then sent through another transformer, which steps it up to around 1000 volts AC, and that's supplied to the strobe light, which will ionize the xenon gas inside. So, once this strobe light turns on, this photoresistor senses a change in light, so it decreases its resistance. Now the photoresistor is in series with a 20,000 ohm potentiometer, and that combination is in parallel with 2 10,000 ohm resistors in series. So the 2 10,000 ohm resistors are always going to have a 2.5 volts between them, and that's hooked up to the inverting input of an op-amp. Now, between the photoresistor and the 20K potentiometer is the non-inverting input to the op-amp. So when you have 2.5 volts on the inverting when in the dark, or just always, I guess, whenever there's a light detected by this photoresistor, the voltage between the photoresistor and the potentiometer is going to go above 2.5 volts, which is going to cause the op-amp to swing from the negative input, or the negative rail, to the positive rail. Now, this output from the op-amp is going to get sent into a transistor, which is going to switch on and amplify the current so that it can power a solenoid. It's also useful to include that the op-amp includes a hysteresis to prevent fast switching between the positive and negative rails. And then once the solenoid is powered, there's a coil inside of it, which is going to have a current running through it and create a magnetic field, which is going to push this plunger so that this metal ball can fall through the hole.
The next element of our circuit is a metal detector, which uses this large coil and an NE555 timer. The NE555 timer is operating in astable mode, which means it's outputting a constant square wave frequency. Without the metal ball, this frequency is higher, and once the ball falls in, this frequency decreases because the steel ball acts as a ferromagnetic core in the coil, which increases its inductance. The output frequency of the NE555 timer is being monitored by the Arduino, in which the on time and off time of the square wave output are being measured, therefore calculating the frequency of the output from the metal detector. If this frequency falls below a defined threshold when the metal ball falls into the coil, power is removed from the gate of our MOSFET, which creates a discontinuity between the drain and source pins of the MOSFET, which deactivates this electromagnet, which holds up this metal object. When the metal object falls, it lands on this button and creates a continuous signal, which is measured by the Arduino. When the Arduino measures a positive voltage from the button, it goes into a play song loop, which is entered into the code, which has an array of note frequencies and durations. These arrays are iterated through in a for loop, in which a note frequency is played for its given duration, which is played through this buzzer. In the arrays, if the note is even, the green light is flashed, and if the number of the note in the array is odd, the red light is flashed. This creates an alternating effect between the green and red LEDs while simultaneously playing "We Wish You a Merry Christmas." This is our full RGM project.
Merry Christmas and a Happy New Year.